everyone! Welcome back to the channel. If you've ever typed something into Google and been amazed at how it understood exactly what you meant, even when you misspelled half the words, you're about to find out why. Today, we're diving into the future of search technology. We're talking about vectors, knowledge graphs, and multimodal AI, the holy trinity that's transforming how we find information online. By the end of this video, you'll understand how search engines are evolving from simple keyword matching to actually understanding meaning, context, and even your images and voice. So, hit that subscribe button and let's get started. Let's take a trip down memory lane. Remember when search engines were basically fancy dictionaries? You had to type the exact keywords to find what you needed. If you searched for Best Italian Restaurant New York, you'd get results that had those exact words. But what if you searched for where to eat pasta in NYC? Totally different results, even though you meant the same thing. This was the era of keyword-based search. Search engines would match your words to documents containing those same words. Simple, but limited. Fast forward to today. Search engines understand intent, context, and meaning. They know that jaguar, the animal, is different from jaguar, the car. They understand questions, not just keywords. So what changed? 3 major innovations: semantic search using vector embeddings, knowledge graphs that map how concepts relate, and multimodal AI that understands more than just text. Let's break down each of these game changers. Okay. This is where things get really cool. Vector search is like giving every word, sentence, or document a unique location in a multi-dimensional space. Imagine if every concept, every word, every sentence had coordinates like latitude and longitude, but instead of just 2 dimensions, we're talking 768 or even 1,536 dimensions. Here's the magic. Words with similar meanings end up close together in this high-dimensional space. Happy is near joyful. Car is near automobile. King minus man plus woman equals queen. Mind-blowing, right? Let me show you how this actually works in code. See, the first 2 queries are about the same thing even though they use completely different words. Vector search catches that. This is why when you search for how to fix a flat tire, Google also shows you results about tire repair and puncture solutions. It understands the meaning, not just the words. Now, let's talk about knowledge graphs. Think of them as the world's largest mind map, connecting facts, people, places, and concepts in a massive web of relationships. When you search for Leonardo DiCaprio, you don't just get a list of web pages. You get a panel showing his movies, age, relationships, awards, all structured data. That's a knowledge graph at work. Knowledge graphs store information as entities and relationships. Leonardo DiCaprio acted in Titanic. Titanic released in 1997. Titanic directed by James Cameron. This creates a web of knowledge where everything is connected. It's how search engines can answer questions like, who directed the movie that Leonardo DiCaprio starred in with Kate Winslet in 1997, without you having to spell it all out? Here's how you might query a knowledge graph. This is incredibly powerful because it doesn't just find documents. It understands relationships and can reason about connections. So we have vector search that understands meaning, and knowledge graphs that understand relationships. What if we combine them? That's exactly what modern search engines are doing. Hybrid search uses both approaches simultaneously. Let's say you search for phones with the best camera under $500. Here's what happens. Step 1. Vector search finds documents about phone cameras and budget phones, understanding the intent and semantic meaning. Step 2. Knowledge graph filters results using structured data, price ranges, camera specs, and brands. Step 3. Results are ranked using both semantic relevance and factual accuracy. Here's a simplified hybrid search. Notice how we weight both approaches: 60% semantic, 40% structured. This balance gives us the best of both worlds. The result is more accurate, more relevant, and more intelligent search results. All right, this is where it gets really futuristic. What if you could search with an image, a voice recording, or even a video clip? You see a cool plant, snap a photo, and instantly know what species it is, how to care for it, and where to buy it. That's multimodal search. Multimodal AI means the search engine can understand text, traditional queries, images, visual search, audio, voice search or music recognition, video, scene understanding. Google Lens is a perfect example. Point your camera at anything, a landmark, a product, text in another language, and it tells you what it is. Here's how it works technically. The breakthrough here is that text and images are encoded into the same vector space. This means you can search images using text or search text using images. Real-world applications: Pinterest visual search, Spotify song recognition, YouTube scene search, medical imaging diagnosis. So what does all this mean for you? How will search actually feel different in the next few years? Scenario 1, conversational search. Instead of typing weather New York tomorrow, you'll say, should I bring an umbrella to my meeting tomorrow? And it'll check your calendar, the weather, and your location to give you a personalized answer. Scenario 2, visual search everywhere. You're watching a show and love the actor's jacket. Just pause, tap on it, and instantly shop for similar styles. No typing, no describing, just point and search. Scenario 3, proactive search. Your search engine won't wait for you to ask. It'll know you're planning a trip based on your recent searches and proactively suggest flights, hotels, and activities. Think about it. 2000s, cheap flights to Paris. 2010s, what's the cheapest way to get to Paris? 2020s, just open your flight app. It shows Paris deals knowing you searched for French restaurants last week. 2030s, your AI assistant books the trip knowing your preferences, budget, and travel style. Search isn't just getting better at finding information, it's becoming an intelligent assistant that understands you. Now, it's not all smooth sailing. There are some serious challenges we need to address. Challenge 1, privacy concerns. For search to be truly personalized, it needs a lot of data about you. Where do we draw the line? How do we protect user privacy while still providing intelligent results? Challenge 2, bias and fairness. AI models learn from human-generated data, which means they can inherit our biases. How do we ensure search results are fair and don't discriminate? Challenge 3, hallucinations and accuracy. Vector search and AI can sometimes generate plausible sounding but incorrect results. How do we maintain factual accuracy? Challenge 4, computational cost. Running these sophisticated models requires massive computing power. How do we make this sustainable and accessible? Here's an example of a safeguard. The good news: researchers are actively working on all of these problems. Privacy-preserving search, bias detection, fact-checking systems, they're all in development. So there you have it. We've journeyed through the evolution of search, from simple keyword matching to sophisticated AI systems that understand meaning, relationships, and multiple types of media. To recap, vector search understands semantic meaning. Knowledge graphs map the world's information. Hybrid approaches combine the best of both. Multimodal AI searches across all types of content. The future of search isn't just about finding information faster, it's about understanding you better, anticipating your needs, and making knowledge truly accessible. In upcoming videos, we'll dive deeper into each of these topics. We'll build our own vector search engine, create a knowledge graph, and even train a multimodal model. So make sure you're subscribed with notifications on. If you found this video helpful, give it a thumbs up. Drop a comment below and let me know, what's the most impressive search result you've ever gotten? What would you want future search engines to do? Check out my other related videos, and I'll see you in the next one. Until then, keep searching, keep learning, and keep being awesome.